Okay, so this is our next lecture. We were discussing about the bills of material MRP in the previous one. So what is bill of material? Let's dissect a bill of material. It is basically a form which lists all the components for assembly and for production. For example, we have to assemble a motorcycle. So we will need details, components, elements. The motorcycle can be dissected into two areas. It will have two segments. One is the chassis and the other is the engine, the powertrain. And powertrain will further get distributed into other departments in areas like motor, gear, and exhaust, while chassis will be divided and further segmented into front wheel, rail wheel, frame, and brake systems. A bill of material contains the description of each component. So we have molecular details, the quantity and unit of measure. Now, unit of measure, motor will be one, which will be each, gear will be each, exhaust will be each, front wheels will be again each, frame will be each, and brake system will be two, front and the back brakes, that will be each. Okay. So if we are dealing with chemicals, then we'll have liters or quantity will be in drums, whatever. So the bill of material lists the quantity and the components. So the bills of material creates relationships between assembly and its direct components. So what are the requisites for making bills of material? Bills of material deal with data that is relevant for production. Okay. From this comes the area of validity, the plant. So a plant has to have it has to have its presence for material to exist, because a material will need either a production plant or a storage area. Without that, you cannot store or produce a material. So the prerequisite is to have a plant. Only based on that, your plant will be the foundation to create a material bomb, because the plant will first have the material before you can make a bills of material. If you want to create a material bomb, there must be a valid material master in the same plant. Many checks also take place when creating items. If you create material components, then plant data must exist for the materials. The materials are needed to accomplish production. Multi-materials are needed in material form. Okay. Bomb allocation in plants. Now, bombs can be can have multiple materials and elements, and it's possible that when you're making your finished or semi-finished product, the raw material gets processed over here and it gets moved to another plant. So we need additional material, additional components from other plant. So material bills of material will have the storyline to describe what components will come from which plant, what material master will be sourced from which material, from which plant. So area of validity will be described within the material bomb for which plant is the bomb applicable. Okay. So it will actually show which plant is basically eligible to supply and produce this material or element of component. So we assign that area to a particular bomb. There can be multiple plants, but some plants are specialized for making that motorbike. Okay. Material bomb in production planning. Now, in production, of course, you need a bills of material in detail. The bills of material contain essential, basic, or master data for integrated materials management and production control. So production will, of course, lean and incline towards a material bills of material. The bills of material results from the product design phase. Now, the design department will actually roll out the requirements. Okay, it will roll out how the model will be rolled out and produced The bill of material results from production design phase, drawings and a list of all the parts required to produce the product. So design department will be responsible. So material BOM can be a responsibility of the inventory and the design department. So components will be required to accomplish by production. And bills of material consists of unit quantity required, how many units of an element will be required to produce one unit. Okay, so the bills of material also consists of material list, description to produce one bike. So if you're making and producing a bike, it's possible that there will be some wastage, scrap, or breakage or leakage. So more of one material will be required. So quantities can increase or decrease. Complete list of formally structured components will be there to make up that product. Okay, to make that finished product. It contains the material number reference as well. Okay. Now there are types of bills of materials like single level. Now this is a motorcycle and it's pretty simple that it needs a powertrain and a sachet. Okay. Oh, sorry, chassis. And this is a single level, no more details, no molecular details, and that's it. This is relevant for small industries. Single level BOM creates the relationship between an assembly and all of its components. Multi-level, it goes into molecular details. It has multiple levels. Different assemblies have components to produce a bike. The categories that we have in bills of material, okay, we have material master record, it will create material. Bills of material, equipment master record will create equipment bills of material. Document info record will have document blueprint to create a machinery or anything or a structure of a building, whatever that actually like in architecture. Architecture will have a workflow, to produce, to construct a building or a bridge. So it will be a storyline outlined in a bills of material. Okay. So equipment, this is basically good for example, construction industry where you're making high skyscrapers and there are boom cranes of different types which need assembly before these are deployed for different projects. So that will require a bills of material that, okay, fine, we need a certain tons of crane or a boom crane to lift either material or blocks or a chiller, which has to be placed on top of that structure, or for any other engineering requirement. And that will require that, okay, fine, we need this much length of a boom, and that can vary. So we will have an equipment bills of material. Okay. Validity period, of course, a bills of material will have a certain validity because different industries will be catering with expiry dates if they have products like that, like for example, food industry, okay, or in automotive industry, we will have models, bike models and car models, which will be valid for 1 year, 2 years, 5 years, and after that, that model will be obsolete and scrapped. After which another new car model will be launched. So there will be a validity period for that as well. So that's how validity helps in keeping your requirements in place. Validity area, the area validity and validity period define the precise conditions under which bills of material applies in different areas of company. Okay, so validity area is your plant and validity period, of course, is what we have discussed. The validity area defines which plants may use or produce an item described by the bills of material. By linking the same bills of material to assemblies or components in different plants, you can extend the bills of material validity area. So you can actually replicate bills of material from one plant to another plant. For example, if the raw materials are being assembled over here, then of course the connection like speedometer connection and speed checking, brake checking will be done over here. Hydraulic fluid checking will be done here. So that material BOM will be extended with more additional components. By linking the same bills of material, in different plan, you can extend the bills of material. An assembly component may have different bills of material for various validity areas. Okay. So you can have a different material BOM here and a different material BOM here based on the process. So how is the BOM used? It's used for various reasons and various categories. Like, for example, it can be used for production order. Production order lists all the process work centers to cater the production of a product, and it's also used for costing for producing a motorbike or anything, any finished product. The components from a production BOM are copied to production order or run schedule. So production order run schedule for repetitive materials. For repetitive materials like beverages. So production order or run schedule. Okay, these components can then be changed if necessary based on the actual production requirements. Bills of material types, as we have seen, simple BOM. Oh no, we have seen single level and multi-level. Single BOM, simple BOM is a bill of material without variants or alternates. Variant BOM is basically a group of bills of material that have been grouped because they share a large proportion of similar parts, like same bike, but it's blue or white. So variant will be blue or variant will be white. It will have a blue seat or white seat. It will have bolts that will be a different color only, not major feature change. And the body will be the blue or white. Multiple BOMs is that you're creating an alternative for example, CD70. No, not CD70 or 125. That is not a good example. You're creating an alternative for example, the same bike but for the mountains and the same bike for the roads. Okay, and this is very much relevant for the tires. In tire industry, you will have alternates like that. Some alternates in automotive will be that some cars or motorbikes are made for different countries, which have different requirements, okay, official requirements. So simple BOM is one way of doing things. Variant BOM is different variant sets and configurations. Different variants like colors, features will be different, but configuration remains same. Multiple BOM alternate available to create same material and finished product. And another way, it's that, for example, in paint industry, you have paints for oil paints, you have enamel paints, and you have distemper. Some require water mixing, some require oil mixing. So oil paints are made on a different machine. Enamel is made on another machine. Okay. So based on that, if you're creating another version, or for example, you have an order from a customer and you want to speed up the production. So you have an Italian machine and you have a Chinese machine. So you will prefer Italian machine because it is more faster, the quality is different, and it is also expensive. So you actually create it as an alternate production version to speed up your production. So that's how you can use multiple BOMs. The structure is pretty simple. It has a header, and then we have sub items for that with the materials. So data that refers to entire BOM is managed under header. Details that refer to specific component are managed under item. A material installed in more than one place in manufacturing assembly, it can be referred as sub item like screws, bolts. Okay, that can be sub items. Or carburetor is basically a part of the motor, so it can be a sub item of that main item. Okay. Some items look same, but positioning on the product is different. Like bolts are required to fix the seat, to fix the speedometer, the handle. So the sub items can be categorized in that way. Categories. Okay, some categories are stock items like the material in stock, like wheels, handles, speedometer. Non-stock item like bolts, screws. Those are not of that material type, material value. Okay, because you actually buy bolts and screws generally, but some of it is also used for production. So it is non-stock item. You don't actually stock it. Variable sized item. Now, variable size is basically where specifications are required but not clear before production, like plates of varied sizes, open sheets. Okay, like spokes of the wheel. are made from sheets. Text item, again, as I said, for use for architecture, for document control, for design. Class item, red color paint versus white color paint, characteristics and features. These are basically based on class items. So item categories can be different in bills of material. Okay. So let's go and check our system. Where is our system? Okay. Okay. SPRO, IMG, production basic data, bills of material. Um, basic data, bills of material, item data, define item categories. Okay. Okay. So here we have um, item symbols, category symbols, and those are compatible unit, stock item, intra material. You can have more. Okay. And these are some defaulted by SAP, like inventory management, text item, variable size item, document item, class item, and so on. You can have your own as well based on uh, categories that you will require in your client's production. Okay, some will be required, some will be not required, some will be optional. Okay, like N. If we look at this, N. What is N? N is non-stock item, so it is optional. N3. Okay. So what is the usage? Usage of bill of material is for operations, costing, order quantity, location data, technical data, for engineering, for plant maintenance, for sales and distribution, costing and production. Okay, simple. Categories. When you create a new BOM, you must assign each component to an item category. So it can be a stock, non-stock, simple. Item category determines features and functions of an item and controls further system processing on that item. So if a stock item, it will be governed by materials management module for costing, stocking, for movement of that item. Non-stock item, yes, it will have a location, but not any material value, net worth, like screws, bolts, pens, pencils. These are non-stock items. These are generally found available in bulk. Okay. Same goes for variable size items like sheets, like iron sheets for building the frame of the motorbike and so on. Usage, we've already covered that. Okay, BOM comparison. Okay. Now, what is a BOM comparison? For example, we have a BOM here and we have another BOM here. And this BOM is being used on one plant or one machine for, as I said earlier, Italian machine, and this is the Chinese machine. Some of the components will be similar and matching, and some will be different. Okay. So, in comparison, of course, we will have a different result set. One will be Italian made, the other will be Chinese made. Explosion of the BOM. Now, why do we actually need to explode the BOM? Because we need to get the molecular details to create a finished item. So there are three ways to explode a bill of material. Multi-level shows by level explosion requirement of material. So multi-level, it basically shows what components will be required at what level. Okay. And the levels will actually show you like C1, C2, A1, these are phases. In first phase, of course, you will need, this is a higher level part of the item. It will then be assembled using C1, C2. Okay, so multi-level will actually show you which part will be required at what point. But of course, the routing will actually show you when to fix that part to make A1 and how many components will be used for that and how it will be assembled. Okay. Where is it used? So components like materials, like a motorbike, components like screws, bolts, and other things like sheets can also be used at other places in plants. So you need to actually track it as an inventory manager or production manager where the material is being used, consumed, and lying, okay, where it is being stored, so that you actually know when is the next consumption coming in and how much of the material will be required. So component usage is basically accomplished using where used list, where the form is being used elsewhere. So where use list will actually show you which plant and which production order is actually requiring and working on that same bill of material. So that can be used for engineering change request, also for ISO checks. Where use these are also used to replace new document procedure with old documents. If a new motorbike model is being launched, the old one, and it is a different variant of the older model with some changes. Of course, that old bill of material will be useful to redefine the new form. Mass changes in bill of material is also possible. Okay, we'll see that. Technical types. We've already seen that multiple bombs, variant bombs, and simple bills of material. Variant bombs, again, as I've already told you, basically the configuration is the same, but slight change in features. Features like black, red, blue. These are some light changes which do not actually change the whole structure of the finished product in a major way. Variant bomb. Now, variant bomb, as I said, the Italian machine versus the Chinese machine, that is the variant form. Or the variant can be CD70 and 125. So up to 99 variants can be stored, okay, and defined. Different material number for each variant. Material numbers can also vary because engine of a 125 is different from a CD70 125. Okay, so there will be a separate header for each variant. Variant bomb is basically governed by a group. For example, we are making a water pump, and this is the model TPF00, and this is TPFX. Same like 125 and CD70, and we have another variant which is F88. This produces water or throws water at a certain speed. This produces at another speed, but it is being made at the same plant. So this is a variant form. Variant configuration again has a lot of variables like color, engine type, speed, speedometer, size, weight. What is that thing called? Road clearance, okay, frame, profile, everything. So variant configuration will actually give your customers a choice to choose their own specific type of motorbike, and it happens in customized orders. Okay. So variant configuration is basically, it has the maximum list of materials that can go into a production, and it will have maximum routing. Combine these both, a customer will pick some of the features from here. The routing, of course, will then be adjusted, and that configured routing and BOM will combine to make a custom order vehicle like Rolls-Royce. Okay. Luxury cars are made in this way. Multiple BOMs, as I've already told you, alternate, as I've already explained earlier. Okay. Blue color, but as in paints, like alternate 1 will use mix of pigment, alternate 2 will use solvent, alternate 3 will use water, good for paint business, as I have already explained earlier. Okay. Multiple BOM. Multiple BOM, it will have selection of alternatives like lot size, date, production version. I've already told you the Italian and Chinese version. Okay. One BOM header per alternative, one BOM header for Italian, one BOM header for Chinese. Variant BOM, again, alternate, there are multiple BOMs in variant BOM. Okay, we've already seen that. Bills of material assignment to plants. Yes, it can be assigned to multiple plants because it is created and defined at client level, so it is independent. Recursiveness. Now, recursiveness, how it is used? It is used for, in easy terms, it's like when you're making yogurt, you make yogurt from milk, okay? And when that yogurt is made, some of the yogurt is still needed to make yogurt from another batch of milk. Okay, so that is recursiveness. So this is milk. So this is yeah, this is yogurt, but it will require milk, some yogurt, and a bit of mixing, temperature, and everything. And again, bit of yogurt again to make it again. Repeat that process again. So it is used also used in chemical industries and pharma to make soluble catalyst and so on. Creating bombs. Okay. Ah, creating bombs. CS01. Okay. Let's say we have double A for two. We're just picking a random material, for example, CD70. Okay. CD70 plant and uh, material type will be finished material, PERT. Okay. And bomb usage. Bomb usage will be for production, engineering, sales distribution, plant maintenance, configuration, customer management. You have many of these categories. You will go for production. Okay. Validity, we'll keep it 2024 0101. Okay. Enter. Does not exist. Okay. It does not exist. What do we have in double A 42? Let's see that. Material group. I guess material group is PK raw. Okay, we have multiple materials here, but I don't know it's the same plant or not. Not maintained in plant double A 42. Okay, material type to get material. Okay, let's check what we have made. MM60 plant double A 42 evaluated materials. Yes, and the same plant. Okay, we have 162 control Y, control C, CS01. So you will have components listed over here. Okay. And what is this concrete filler? So what will be needed to create this finished material? All the components will be listed here with quantities and unit of measurement. Okay. Simple as that. So that was that and end of our lecture. I hope you enjoyed.